What you're looking at is not just a rocky, barren landscape from some remote corner of Earth. This is Mars. Every rugged ridge, every dusty valley, every distant hill is part of a world far away. 13 years ago, NASA embarked on a groundbreaking mission when it sent the Curiosity rover to Mars. And just 3 years ago, it sent another marvel, Perseverance, to join the ongoing exploration. Their mission is to map this alien planet, peer into its secrets and search for clues to its ancient past. Now, after years of patient, meticulous work, these rovers have sent back images that defy belief and have taken our understanding of Mars to new heights. We're not just seeing pictures, we're witnessing history. But what exactly are we seeing, and what has been the journey of these rovers since they first touched down on the Red Planet? Mars, or as we often call it, the Red Planet, has fascinated mankind for centuries. From ancient astronomers observing its blood-red glow to modern scientists launching probes, Mars has always been more than just another celestial body. Until the space age, however, it remained distant, almost unreachable. It wasn't until the mid-20th century that humanity had the technology to get up close and personal with Mars. The journey began with NASA's Mariner 4 mission in 1964. This historic flyby gave humanity its first glimpse of the Martian surface. Mariner 4's images were grainy, monochrome, and limited, but they revealed something startling. Mars was not the world of oceans and lush landscapes we had imagined. Instead, it was rocky, desolate, and cratered, more like our moon. These first images rewrote history and ignited our desire to know more. With the success of Mariner, NASA stepped up its efforts. The 1970s saw the launch of the Viking program, with 2 missions, Viking 1 and Viking 2, each consisting of an orbiter and a lander. Viking was groundbreaking in many ways. It was the first time we had successfully landed on another planet and conducted experiments to search for signs of life. Viking 1 and 2 took samples of Martian soil, analyzed atmospheric data, and sent back thousands of images of the surface, showing us the haunting beauty and raw desolation of Mars. While Viking didn't confirm life, it provided invaluable insights into the Martian atmosphere, weather, and soil. Even today, scientists are still studying Viking's findings to better understand the Red Planet. The Viking missions were monumental steps forward, paving the way for even more ambitious missions in the decades that followed. The 1990s marked another giant leap for Mars exploration. NASA launched the Mars Pathfinder mission, a low-cost, high-impact mission that would land the Sojourner rover. Sojourner was a small rover, about the size of a microwave oven, with 6 wheels that could navigate the Martian terrain, analyze rocks, and study soil composition. It was a massive achievement and a testament to human ingenuity, proving that we could land, move around, and collect data on Mars, opening up a whole new era of Mars exploration. But why are we so focused on Mars? Why not explore Venus, Mercury, or other planetary bodies? Mars is unique in many ways. It is the most Earth-like planet in our solar system, with features such as polar ice caps, seasonal weather patterns, and a day almost as long as Earth's. Understanding Mars helps us draw parallels and contrasts with the history and future of our own planet. Mars may also offer a potential home for humanity. As Earth faces unprecedented challenges, including climate change, overpopulation, and environmental degradation, Mars could provide a second chapter for humanity. But before we can consider colonizing it, we need to know everything about it, and that's where our rovers come in. The first Mars rovers, Spirit and Opportunity, were a breakthrough in planetary exploration. Designed to last just 90 days, the twin rovers far exceeded expectations, and Opportunity has been exploring Mars for almost 15 years. Spirit roamed the Gusev crater, while Opportunity made amazing discoveries in the Meridiani Planum region, including evidence of past water activity on Mars. These rovers were a triumph of engineering and endurance, braving dust storms, extreme temperatures, and rough terrain to deliver insights that reshaped our understanding of Mars. Their success inspired NASA to dream bigger. NASA's Mars Science Laboratory mission introduced Curiosity, a next-generation rover with unprecedented scientific capabilities. Launched in 2011, Curiosity landed on Mars in August 2012 in the Gale crater, a site chosen because it was believed to have once held liquid water and perhaps life. Curiosity's descent, known as the 7 Minutes of Terror, involved a complex sequence of events, including a first-ever sky crane maneuver to ensure a safe landing. Curiosity, about the size of a car, is equipped with advanced tools such as the ChemCam, which fires a laser to vaporize rocks and analyze their composition, and the sample analysis at Mars' SAM laboratory, which tests for organic compounds, essential markers of potential life. Unlike previous rovers, Curiosity is powered by a radioisotope thermoelectric generator, RTG, allowing it to operate continuously through Mars's harsh seasons. Naming the rover was a meaningful process, with NASA holding a contest won by 6th grader Clara Ma, who suggested Curiosity because curiosity is the force that drives us forward. Her words captured the spirit of exploration, making Curiosity the perfect name for this mission. Since landing, Curiosity has made remarkable discoveries, including detecting organic compounds in Martian rocks and observing methane fluctuations in the atmosphere, hints that Mars may be geologically active or could even harbor microbial life. Its observations of ancient water deposits in Gale crater suggest Mars was once a warm, wet planet with potential to support life, helping scientists piece together Mars's transformation to the arid, barren world we see today. Building on Curiosity's success, NASA launched Perseverance in 2020 with an ambitious goal: to search for signs of ancient life. It landed in Jezero Crater, a site that may have once held a lake with a river delta, a prime location to search for preserved microbial life. Perseverance's landing was another 7 minutes of terror, enduring high-speed entry, parachute deployment, and a sky crane landing. Perseverance features redesigned wheels for rugged terrain, a suite of advanced scientific tools, and the groundbreaking MOXIE experiment, designed to produce oxygen from Mars's carbon dioxide-rich atmosphere. MOXIE successfully generated enough oxygen to sustain an astronaut for a few hours, a crucial step towards supporting human missions by allowing astronauts to live off the land. Perseverance also carries 19 cameras capable of capturing high-definition images and videos. With its advanced drilling system, it collects rock samples, sealing them in tubes for a potential return to Earth, an unprecedented effort in space exploration. Naming Perseverance was also a student-led process, with 7th grader Alexander Mather suggesting the name to embody humanity's relentless pursuit of knowledge. Accompanying Perseverance was a small, lightweight helicopter named Ingenuity. Originally intended for just 5 flights, Ingenuity has conducted dozens, scouting terrain and mapping paths that rovers alone could not access. Its success has proven that controlled flight on Mars is possible, opening new avenues for exploration. Perseverance has already made fascinating discoveries, identifying various types of rocks in Jezero Crater, including rocks that interacted with water. In an area called Wildcat Ridge, it found sediments likely formed in a standing body of water, suggesting this area may have been habitable in Mars's ancient past. However, MOXIE's success in producing oxygen on Mars might be the most significant milestone, as it reduces the need to transport oxygen from Earth, paving the way for future human exploration. Mars exploration is far from over. NASA, in collaboration with the European Space Agency, is working on a Mars sample return mission, which will involve landing a retrieval vehicle on Mars, collecting samples from Perseverance and Curiosity, launching them into Mars orbit, and returning them to Earth. If successful, Martian soil samples could be in scientists' hands by 2033, potentially holding secrets about Mars's history, geology, and maybe even its potential for life. Studying these samples could bring us closer to answering the age-old question: are we alone in the universe? Mars isn't just a scientific destination. It's a frontier that could one day become humanity's new home. NASA and private companies like SpaceX are developing the technologies needed for human missions to Mars. SpaceX, led by Elon Musk, has ambitious plans to build self-sustaining colonies on Mars using the Starship spacecraft. Musk envisions a thriving human settlement on Mars, where people could live independently of Earth. Starship, a fully reusable spacecraft, is key to this vision, capable of carrying people and supplies, with SpaceX also exploring ways to utilize Martian resources for water, oxygen, and building materials. NASA, too, is focused on human exploration, collaborating with SpaceX to develop habitats, life support systems, and other essential technologies for surviving on Mars. Our journey to Mars is just beginning, but each mission brings us closer to the ultimate goal of sending humans to Mars and eventually establishing a permanent presence there. For now, robotic explorers like Curiosity, Perseverance, and Ingenuity continue to pave the way, uncovering secrets and preparing Mars for humanity's arrival. Would you want to live on Mars? Could you imagine waking up on a different planet with Earth a distant blue dot in the sky?